In this episode, we take a careful look at how strong security operations keep improving even after the immediate urgency of an incident has passed. The big idea is that every incident produces information that is far more valuable than a simple story about what went wrong. Post-incident data shows how your environment behaved, how your team made decisions, where your visibility was strong, and where uncertainty forced guesswork. Continuous improvement, CI, is the discipline of capturing that data and turning it into changes that make the next incident easier to detect, easier to scope, and easier to resolve with less disruption. For brand new learners, it helps to realize that the best programs do not rely on memory or opinions to improve, because memory is selective and opinions can be political. They rely on evidence from what actually happened and what actually slowed them down. Then they use that evidence to grow capability in a steady, repeatable way. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to understand CI is to see it as a feedback loop that turns real-world performance into better future performance. An incident is like a stress test that reveals both technical weaknesses and operational weaknesses, sometimes in ways that routine monitoring never exposes. The feedback loop begins with capturing what happened, but it does not stop at storytelling, because stories can be vague and comforting. It moves into analysis of what signals appeared, how long it took to notice them, what evidence was missing, what steps created delay, and what decisions were made under uncertainty. From there, the loop produces prioritized changes, assigns ownership, and verifies whether those changes actually improved outcomes. The reason this is called continuous is that improvement is not a one-time project that ends when the report is written. It is a regular operational rhythm where incidents, near misses, and even false alarms become learning events that shape detection, response, and planning. When this rhythm is healthy, the organization gets stronger after each disruption instead of merely recovering and moving on. Post-incident data can include many kinds of information, and learning to recognize what is most valuable is part of building maturity. Some of the data is technical, such as event traces, authentication records, network observations, and configuration changes that show the attacker path and the defensive response. Some of the data is operational, such as timestamps for when alerts fired, when triage began, when escalation occurred, and when containment and recovery actions were completed. Some of the data is human and procedural, such as who was contacted, how quickly approvals were granted, what information was repeatedly requested, and where confusion or miscommunication occurred. Even the absence of data is valuable because missing evidence points to a visibility gap that likely exists beyond this single incident. For beginners, it is important to avoid thinking of post-incident data as only forensic evidence, because the data you need for CI is broader. It is anything that helps you understand how the system behaved and why the response moved the way it did. A key step in using post-incident data is turning it into a timeline that is reliable enough to support decision-making improvements. A timeline is not just a sequence of attacker actions, because it is also a sequence of defender awareness and defender choices. You want to know when the first suspicious signal existed, when it became visible to monitoring, when it became visible to a person, and when it was acted on. These are different moments, and the gaps between them are where improvement often lives. A timeline also helps you identify false starts, such as early hypotheses that were later disproven, and it shows whether those false starts were reasonable based on the evidence available at the time. When you include defender steps, you can see where work paused due to waiting for information or waiting for permission, which reveals process bottlenecks. This is how timelines stop being historical documents and become tools for operational change. If you can point to where time accumulated and why, you can propose changes that reduce that delay next time. Another foundational idea is distinguishing between symptoms, root causes, and contributing conditions, because CI is most powerful when it targets conditions that will matter again. A symptom might be a flood of suspicious logins or a service that became unstable, but symptoms do not always reveal how the incident began. A root cause might be credential compromise, an exposed weakness, or a misconfiguration, but even a correct root cause statement can be too narrow if it ignores why the environment allowed the damage to grow. Contributing conditions can include overly broad privileges, weak segmentation, missing monitoring on critical assets, unclear ownership, or slow escalation pathways. These conditions are often the true opportunity for growth because they shape multiple incidents, not just this one. For beginners, it is tempting to think that fixing the root cause ends the story, but many repeat incidents happen because the same conditions remain and attackers simply use a different entry point. When you use post-incident data to identify contributing conditions, you begin improving the system as a whole. That is what makes CI durable rather than reactive. CI also requires you to translate observations into clear improvement opportunities, which means moving from what happened to what should change. If post-incident data shows that triage took too long because alerts lacked context, the improvement opportunity is not to tell analysts to work faster, but to enrich signals so decisions can be made with less searching. If data shows that containment decisions were delayed by uncertainty about asset criticality, the improvement opportunity is to improve asset context and ownership clarity so priority decisions are faster. If data shows that the team could not confirm scope because key telemetry was missing, the improvement opportunity is to improve data collection, retention, or normalization on the assets that matter most. If data shows repeated miscommunication, the improvement opportunity might be a standardized update rhythm and a single shared incident status view. The goal is to define opportunities in a way that is specific, actionable, and tied to evidence, because vague lessons do not produce change. When the improvement is defined clearly, it can be assigned, tracked, and verified. Prioritization is the moment where CI becomes real, because an incident can produce dozens of lessons, and the organization cannot address all of them immediately. Post-incident data helps prioritize by showing which issues created the most delay, the most risk, or the most rework. High-impact priorities often come from patterns that repeated during the incident, such as analysts repeatedly lacking the same piece of information, repeatedly escalating to find the same owner, or repeatedly validating the same decision because no standard playbook existed. Prioritization also depends on risk, because some gaps create the possibility of high-impact recurrence, while others are primarily efficiency issues. A mature approach balances quick wins that reduce friction with strategic investments that improve visibility and control. For beginners, it is important to see that prioritization is not about picking what feels easiest, because easy fixes that do not address the constraint may not change outcomes. It is about choosing changes that will measurably reduce uncertainty and response time the next time you face similar pressure. Turning improvement opportunities into action requires ownership and clear expectations, because post-incident enthusiasm fades quickly when daily work returns. Each improvement should have a responsible owner who can coordinate changes, manage dependencies, and report progress in terms that connect back to the original data. Ownership is especially important when improvements require cooperation across teams, such as logging changes, access adjustments, or business workflow changes, because without coordination, these improvements stall. Expectations should include what will be changed, how success will be measured, and what the likely side effects are, because improvements can create temporary noise or temporary disruption. For example, increasing visibility might initially increase alerts, and that should be understood as a transitional phase rather than as failure. For beginners, it helps to think of CI as operational project management anchored in evidence. The evidence motivates action, the plan organizes action, and the measurement verifies action. Without these pieces, lessons learned becomes a document rather than growth. Verification is the part of CI that prevents an organization from claiming improvement without actually getting better. If an improvement was supposed to reduce triage time for high-impact signals, you should see that time decrease in a sustained way, not just for a day, but across enough cases to suggest real change. If an improvement was supposed to reduce false positives in a noisy category, you should see a reduction in volume and rework without losing detection coverage. If an improvement was supposed to close a visibility gap, you should see that investigations can now answer key questions that were previously impossible. Verification also means watching for unintended consequences, such as a reduction in alert volume caused by disabling a detection rather than improving it. Post-incident data provides the before picture, and ongoing measurement provides the after picture, so improvement becomes a measurable change rather than a feeling. For beginners, this is a vital mindset shift because it treats operations as something you can steer and validate. When improvements are verified, trust grows, and that trust makes it easier to invest in the next improvement cycle. One of the most powerful uses of post-incident data is strengthening detection by converting real incident patterns into better signals. If the incident involved a particular sequence of events, such as unusual authentication followed by privilege changes and access to sensitive systems, that sequence can inform improved detection logic that surfaces similar patterns earlier. If the incident involved a blind spot, such as activity on a critical system that was not logged, the improvement might be ensuring that system produces the necessary telemetry to support future detection. Post-incident data also reveals which alerts were meaningful and which were distractions, which helps tuning efforts focus on signal quality rather than signal quantity. It can even reveal which contextual details were most helpful in triage, such as asset role and user role, which can guide how detections should enrich alerts. The goal is to reduce the chance that the same behavior will remain invisible or ambiguous next time. When detection improves based on real events, it becomes more relevant and more trusted because it is grounded in evidence rather than theory. Post-incident data is equally useful for improving playbooks and investigative consistency because incidents expose where teams improvised and where that improvisation caused delay or error. If analysts repeatedly asked the same questions in different orders, or if different analysts handled similar signals differently, the data can reveal where a playbook would reduce variation. A strong playbook is not a rigid script, but a sequence of high-value questions and evidence checks that reduces wandering and helps analysts reach defensible conclusions faster. Post-incident review can also show which decision points were confusing, such as when to escalate, when to contain, and how to choose between containment options, and those points can be clarified through guidance and shared criteria. Playbook improvements often produce compounding benefits because they speed onboarding, reduce rework, and improve communication with partner teams. For beginners, it is important to connect this to quality under pressure, because playbooks are how you preserve good judgment when stress and fatigue are present. When playbooks are improved using real incident data, they become practical and respected rather than theoretical and ignored. Another growth area driven by post-incident data is process and coordination, because many operational delays have nothing to do with technical difficulty and everything to do with how people and teams interact. Incidents often reveal that access requests took too long, that approvals were unclear, that responsibilities were ambiguous, or that communication channels were noisy and contradictory. These problems are not solved by better detection alone, because even perfect detection cannot move faster than an organization's decision-making pathways. CI uses post-incident evidence to make these issues concrete, such as showing how long a case sat waiting for a specific decision or how many times ownership had to be rediscovered. With that evidence, you can justify changes like clearer on-call paths, predefined escalation criteria, and a shared incident status rhythm that reduces confusion. For beginners, this is an important leadership lesson because it shows that resilience is built through coordination as much as through technology. When coordination improves, containment and recovery become faster and less disruptive, and that is measurable improvement. Post-incident data can also fuel strategic visibility improvements by revealing where the environment produces uncertainty that cannot be resolved quickly. Sometimes the team has signals but cannot interpret them because context is missing, such as not knowing whether a system is critical or whether a user action is expected. Sometimes the team cannot build a reliable timeline because timestamps are inconsistent or event sources are incomplete. Sometimes the team cannot confirm scope because important assets are not producing logs or the logs are not retained long enough. These visibility issues create recurring pain because they force responders to make high-stakes decisions with incomplete evidence. CI uses the incident as proof that certain telemetry and context are not optional if the organization wants faster, safer decisions. For beginners, it helps to think of visibility improvements as enabling future speed and accuracy, not as collecting data for its own sake. The right visibility reduces time spent chasing basic facts and increases time spent on interpretation and control. When visibility investments are driven by real incident lessons, they are easier to prioritize and easier to defend. A mature CI program also treats near misses and false alarms as data, because waiting for major incidents to learn is too slow and too painful. A false alarm might reveal a detection that is too noisy, a context gap that makes benign behavior look suspicious, or an investigation workflow that wastes time. A near miss might reveal that detection worked, but response coordination was weak, or that containment actions were delayed even though the signal was clear. These smaller events provide frequent opportunities to tune, refine playbooks, and improve data quality without the full cost of a major disruption. For beginners, this is a powerful idea because it shows how growth can be continuous rather than episodic. You do not need to wait for a crisis to improve. You can learn from the everyday friction that appears in normal operations. When the organization treats these events as learning inputs, the improvement loop runs more often and becomes more stable. Over time, this steady rhythm is what builds true maturity. Finally, it is important to remember that CI is as much about culture as it is about process, because post-incident learning only works when people are willing to be honest about what was unclear and what was difficult. If post-incident discussions turn into blame, people will hide uncertainty, minimize mistakes, and present a clean story that teaches nothing. If the environment encourages learning, people will share where they were confused, what evidence they lacked, and what decisions felt risky, which produces far better improvement opportunities. Culture is reinforced by how leaders use metrics, because metrics can be used to punish or to guide learning. The healthiest approach uses post-incident data to improve systems and workflows, not to shame individuals for outcomes shaped by constraints. For beginners, this matters because it explains why some organizations keep repeating the same failures despite having talented people. Without a learning culture, talent is wasted in repeated chaos. But with a learning culture, the organization compounds improvement even with limited resources. In closing, CI is the discipline of turning post-incident data into sustained growth that makes security operations faster, clearer, and more resilient with every cycle. Post-incident data includes technical evidence, operational timing, and coordination signals, and it becomes most valuable when it is organized into timelines that reveal where uncertainty and delay accumulated. By distinguishing symptoms from root causes and contributing conditions, you target changes that will matter again rather than fixes that only address one event. Clear improvement opportunities, prioritized by impact and risk, become owned actions that can be executed and verified through meaningful measurement. Detection tuning, playbook refinement, visibility investment, and coordination improvements all become stronger when they are driven by real incident lessons rather than abstract theory. When the learning loop runs consistently and the culture supports honest reflection, the organization stops repeating the same pain and starts compounding capability. That is what it means to fuel future growth from post-incident data, because every incident becomes not just a disruption, but a source of measured, durable improvement.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.